Today you are going to graph a system of equations. And what that means is you are going to make two lines and figure out the point where the two lines intersect. All right, so here's example number 1. We're going to start by graphing the line y equals 3x minus 2. So this part here, the last part, is actually where we start. So that is the y-intercept. So we're going to put a dot along the y-axis at -2, so right there. Then our slope is 3. If it's not a fraction, you can make it a fraction by adding a 1 to the bottom. Whoops. So rise over run, and we always run to the right. So we're going to go up 3 over 1. Now we're going to start at the point we already made, up 1, 2, 3 over 1. Up 1, 2, 3 over 1. Up 3 over 1. And then we're going to connect those dots. So you can click on the little blue circles to extend that line. All right, for the next one, y equals -x plus 6. So this time our y-intercept is going to be at +6. So on the y-axis, we're going to put a dot up here at +6. Great, our slope is negative. There's no number there. If we lost an x box, we lost one x box. And we can also make that a fraction by giving it a denominator of 1. So we're going to go down 1 over 1, and we always go to the right. So from that dot we just made, down 1, right 1. Repeat. Down 1, right 1. There's already a dot there. Down 1, right 1. Right. I'm going to just leave it at that because I already found the dot where the two lines connect or overlap. So this dot right here, that is our point of intersection. Let me get up and dance for a minute to turn the light back on. Okay. So the coordinates of this point is our solution. So if we start at the origin, we'd have to go over 1 on the elevator and go up 1, 2, 3, 4. So the answer then is 2, 4. I didn't know that was already there. Okay. Now it makes sense. All right, let's try another one. All right. For the first one, our y-intercept is at -2. Our slope is 3, so we're going to go up 3 over 1. Repeat, up 3 over 1. Up 3 over 1. All right, there we go. And the next one, our y-intercept is +3. And our slope is also 3. So up 3 over 1. I'm kind of out of space. I could put another one here because from here I would go up 3 over 1. Same for here. And then let's connect them. All right, these lines are parallel. They will never cross. We could also tell that they are parallel because the slope is 3 for both of them. Okay, they will never cross. So therefore, the answer is called no solution. All right, this one, we have y equals 3x minus 2. I feel like one of these equations is supposed to be different. All right, so I'm going to start with the first one. Y-intercept of -2. And then our slope is 3. So I'm going to go up 3 over 1. Up 3 over 1. Up 3 over 1. Okay, in this one, I'm going to change it to also that. Okay. Technically, you might have a harder one where it's not in slope-intercept form. It might instead say standard form, which would be 3x minus y equals, and we have to change that one to a +2. So it might be written like this, where if you got y by itself, it would then be the same exact line. And when you have two of the same exact line and they're overlapping each other, they have all of these points in common. And it's not just the ones that we notice. There's technically a point like right here. I mean, it might be like using a fraction or decimal, but that's okay. So if you have two equations where the lines are exactly the same, then we say there are infinite solutions because there's a whole bunch of points all the way along this line, okay? They could have also tried to trick you too for the slope, and they might also have something that says like 6 over 2, which is the same as 3. So they might make it look different, but it's still the same. So same exact equation, infinite solutions. Parallel lines, no solution because they're never going to cross. And then the ones that do cross, it is the point where the two lines come together.